Module 12.1, Anatomy of the Vocal Tract. In the last set of modules, we looked at how the source and filters cause musical instruments to sound the way they do. In this set of modules, we're going to look at the human voice. The vocal tract is composed of four main parts: the larynx, the pharynx, the oral cavity, and the nasal cavity. The larynx contains the sound source mechanism. The vocal folds, often referred to as vocal cords, are the source for the voice. Here's how they work. The vocal folds are closed tightly so that no air can escape. Pressure from the lungs builds up and causes the vocal folds to open. As the air passes through, they close again. The rate of vocal fold opening and closing determines the pitch of the voice. It's directly proportional to the tension of the vocal folds. More tension results in a higher pitch. Males putting a lot of tension on their vocal folds can sing in a high-pitched tone, which is called falsetto. Pitch is also affected by the mass of the vocal fold tissue. Large vocal folds will vibrate at a lower frequency. This is similar to how a string vibrates, directly proportional to tension and inversely proportional to mass. The length of the vocal folds do not affect frequency in the same manner as the length of a string. In order to increase tension, vocal folds lengthen. As the vocal folds open and close, puffs of air come through, similar to what happens with the buzzing lips of a brass player or vibrating reed from a woodwind player. The puffs of air produce pulse waves, which, by now, you know, are rich in frequencies. Another source for the voice is airflow. When you are breathing normally, the vocal folds are wide open. This is also the vocal fold position for non-voiced speech, for sounds like h, f, sh, and s. Up to this point, when speaking about source filter theory, the filters we've looked at don't change. That is, the shape of a clarinet or the body of a violin does not change as the musician plays different notes. We saw this when we looked at the spectrum of a bassoon playing several octaves of notes. The human voice is very different because it has a variable filter. The timbre of the voice is determined by the three resonating chambers: the pharynx, oral, and nasal cavities. For most sounds, an air column is formed in the pharynx and the oral cavity. This resembles a tube with one end open at the lips and one end closed at the vocal folds, and so it is characterized as a quarter wave resonator. The length of this air column affects the resonant frequency. Because it is not a perfectly cylindrical tube, all harmonics will be present. It also has properties of a Helmholtz resonator, with the space in the oral cavity being the volume, the opening of the lips being the area, and the pursing of the lips changing the length. As you raise your larynx, open and close your lips, move your tongue and jaw, you are changing the variables of the Helmholtz resonator. The shape and size of these parts of the vocal tract cause resonances which we refer to as vocal formants. We will take a closer look at how the changes in the vocal tract affect the sounds of speech in the next module. To review, the vocal tract is composed of four main parts: the larynx, the pharynx, the oral cavity, and the nasal cavity. The larynx contains the vocal folds, which are the sound source. The rate of opening and closing of the vocal folds is directly proportional to the tension and indirectly proportional to the mass of the vocal fold tissue. The vocal tract is a variable filter. It is a combination of a tube and a Helmholtz resonator. The shape of the pharynx, oral, and nasal cavities determine the timbre of the voice. Vocal tract resonances are called formants.